Now this is not something we do very often with double angles identities, but we can use these to prove identities. So we're just going to do this as a regular proof. Again, we need to show our algebraic steps. We need to show left side and right side. One of the things that we should recognize is a couple of these, and again, these are some strategies that we need to make sure we start putting in our tool belt. We have a double angle here and all single angles here. Okay, so we need to somehow resolve that. So we're going to need to convert that into a single angle identity. Here we have a binomial, okay, where here we have only one term. Okay, so it's a monomial expression. So we probably need to deal with that cos and make it into a binomial with one of our identities, which in fact they all are binomials, which will help us out. Here we also have secant, tan. So one of the things I'm going to do first of all is multiply this out, and I'm going to write this all in terms of sine and cos. Okay, so this becomes 2 sine squared x over cos squared x. Okay, well there's a tan x right there. Okay, so those seem to match. So I need to generate sine squared here. That's going to be multiplied by tan squared. So I'm going to actually use, in this case, one of the three identities I have choice of 2 cos squared x minus 1. And I have sines 1 minus sines 2 sine squared. I'm going to use this one because when I write this out like this, we need that cos squared actually to cancel out. We need to get rid of that cos squared, end up with sine squared. Okay, so if I had sine squared, the sine squared version doesn't cancel out with the denominator cos squared with the tan. Okay, so when I multiply this out, this seems to work out quite nicely actually, because I'm going to end up with 4 cosine squareds cancel out, so I end up with sine squared x. Okay, then I get 2 times negative 1 is minus 2, and we get our 2 sine squared x over cos squared x. So I have my left side equal my right side, and my identity is proved. This next one here, we can look at this, and one of the strategies is here we have a fraction. Here we have kind of an expression. Although I could generate a fraction here, which I probably should. I've got a fraction here. I need to convert this into one term or break this up into 2 terms. I think it's much easier to get a common denominator, and once we get a common denominator, often the left side starts to look more like the right side. So that's what I'm going to do first. So I'm going to end up with cos alpha minus sine alpha plus cos alpha plus sine alpha. Okay, and then the common denominator, when I multiply those things together, I get cos squared alpha minus sine squared alpha. Okay, so the signs are going to cancel out. I end up with that double angle identity for cos in the denominator. Well, I think maybe that's what I'm going to do here. I'm going to break that up into sine 2 alpha over cos 2 alpha, because now I'm starting to get a match here. These two expressions start to match. And I don't like that cosecant, so I'm just going to write it in the denominator as 1 over sine. Okay, so see, once I start getting pieces that match, okay, I know I'm on the right track. So that piece matches that piece. I want to cancel out some things here, so I'm going to cancel out those. So on the left-hand side, I'm going to simplify that. Okay, so I'm going to end up with 2 cosine alpha over, I think I'm just going to leave that as cos squared minus sine squared, and I'm going to change the one on this side. Okay, so I'm just going to do that. That's going to be cos squared alpha minus sine squared alpha. I'm not going to touch that anymore because those match already. I have 1 over sine alpha, and I need to decide, well, I have no choice. 2 sine alpha only has one identity, and I need to make it a single angle identity. So there it is. Oh, well, conveniently what's going to happen is, usually this happens once you get pieces matching, The other pieces just fall into place. So I'm going to cancel out those signs, and then I have my left side equal my right side. Okay, so I end up with 2 cosine alpha over cos squared alpha minus sine squared alpha, and that's going to match my left hand side. Okay, there's my identity proven.